Welcome to this training module. Today, our main focus is on providing prompt engineering guidelines and techniques for AI-powered business solutions. Let's get started. Welcome to our first slide on prompt engineering in business solutions. What exactly is prompt engineering? It is the deliberate design of instructions that guide AI models to produce reliable outputs. The basics involve understanding that AI models do not inherently infer human intent. They rely entirely on the clarity and context provided in a prompt. Why does this matter? In enterprise environments, effective prompt engineering ensures content accuracy, reduces incorrect information, and drives consistency across workflows. How do we achieve this? By establishing structured patterns rather than ad hoc, unstructured questions. As a deep dive, treating prompt design as a strategic part of solution architecture directly influences downstream outputs, process quality, and governance compliance. Looking at the diagram on your screen, you can see the foundational flow of prompt engineering. We begin on the far left with the business intent. Because the AI cannot guess this intent on its own, it must pass through the deliberate prompt design node. This is where your skills as a solution architect come into play. Once carefully constructed, the instruction is fed to the AI model node, which then generates a reliable output. Finally, this systematic approach leads to the ultimate goal on the right, consistent enterprise value. This flowchart clearly illustrates that an AI model is only as powerful and effective as the structured prompt driving it. Now let's explore the core guidelines for effective prompting. What are the foundational pillars? Microsoft's guidance emphasizes 4 core areas: clarity, context, format, and constraints. For the basics, you must describe tasks in direct, unambiguous terms, replacing open-ended verbs with clear, actionable descriptions. Why is this critical? Because clear and specific prompts drastically reduce ambiguity and ensure high-quality model responses. How do you implement this? You must always provide necessary context, such as the business purpose and target audience, and define the exact output structure, like JSON or bullet points. For a deep dive, consider the importance of constraints. Constraints keep the AI within acceptable boundaries by defining the tone, exclusions, and data usage limits. For example, establishing explicit "do not include" rules reduces risk and enforces alignment with strict enterprise governance standards. This diagram breaks down the anatomy of an effective prompt into its 4 core pillars. At the top, we have the prompt itself, branching down into clarity and specificity, which ensures you are using direct and actionable verbs. Next is context and background, which anchors the AI directly in your specific business purpose. The third branch is format and output control, dictating the exact structured output required from the model. Finally, constraints and guardrails establish the boundaries and rules the AI must follow, which directly leads to reduced risk. By consistently checking every prompt against these 4 nodes, you ensure predictable, governed, and safe AI behavior. Let us discuss standard prompt patterns, starting with the most foundational: instruction plus context plus output. What is this? It is a proven, structured pattern that organizes instructions logically for the AI model. The basics involve splitting your prompt into 3 clear and distinct sections: what the model must do, the relevant data or business conditions it should consider, and the desired format and tone. Why do we use this pattern? Because this rigid structure ensures clarity and predictability across all enterprise AI interactions. How do you apply it? Simply format your prompt text to literally include these sections, feeding the AI exactly what it needs without mixing commands. Diving deeper, this specific pattern is foundational when designing custom prompts in tools like Copilot Studio. Separating the core instruction from dynamic grounding data prevents model confusion and ensures high reliability. Take a look at this sequential flowchart. It illustrates the instruction, context, output pattern perfectly. The flow starts on the left with instruction, clearly stating the exact task the model needs to perform. This flows directly into context, where we supply the relevant background data and business rules. From there, we move into the output node, dictating the exact format, length, and tone required. By following this strict sequence, the prompt naturally resolves into the final node, a predictable AI response. This visual represents a foolproof assembly line for crafting reliable enterprise prompts, guaranteeing the AI understands its boundaries at every step. Slide 4 covers advanced techniques, role prompting, and few-shot examples. What are they? Role prompting assigns a specific persona to the AI, while few-shot prompting provides sample inputs and outputs. The basics involve starting a prompt with phrases like, act as a cloud solutions architect to give the model a professional frame of reference. Why do we use these techniques? Role prompting rapidly aligns behavior with business purpose, while providing examples helps the model generalize patterns and significantly reduces variance. How do you implement few-shot prompting? You simply embed 2 or 3 examples of perfect inputs and outputs right inside your prompt instructions. In our deep dive, using these patterns is how you bridge the gap between generic AI answers and highly specialized, accurate domain responses. It forces the model to adopt the exact professional standards and formatting your business requires. This diagram maps out how advanced prompt patterns elevate AI performance. Starting at the top with advanced prompt patterns, the flow splits into role prompting on the left and few-shot examples on the right. Notice how role prompting leads to shapes AI perspective, which instantly gives the model a specific, professional persona. Meanwhile, few-shot examples lead to demonstrates desired style, showing the AI exactly what success looks like rather than just describing it. Both of these powerful techniques converge at the bottom node, accurate domain responses. This shows how combining a specific persona with concrete examples is the ultimate recipe for specialized, high-quality AI outputs. Next, we tackle complex workflows using multi-step prompts and chain-of-thought reasoning. What is this approach? It involves breaking large, convoluted tasks into sequential, smaller interactions. The basics of chain-of-thought involve asking the model to explicitly show its steps or reasoning before delivering a final answer. Why is this critical? Because decomposing tasks improves overall quality and drastically reduces model error propagation. How do you build this? Instead of asking for a final answer immediately, you instruct the AI to first extract data, then analyze it, then recommend solutions, and finally summarize the result. Deep diving into this, showing reasoning steps improves correctness in complex tasks like data troubleshooting or architecture decision justification. By forcing the AI to think out loud, you can easily audit its logic and ensure enterprise-grade accuracy before the final output is consumed. Our flowchart here perfectly visualizes the multi-step prompt flow technique. We begin on the far left with a complex business task. Rather than overwhelming the AI model and asking for an immediate answer, we pass it through a logical pipeline. First, the AI is instructed to extract the necessary data. Then, it moves to analyze that specific data in isolation. Next, it generates a recommend step based purely on the analysis. Finally, it reaches the summarized node for human consumption. This step-by-step decomposition ultimately leads to a high-quality result on the right. This diagram proves that pacing the AI through logical milestones is much safer than demanding an unverified answer. Prompt engineering is never a one-and-done task. It requires an iterative refinement loop. What is this loop? It is the continuous process of testing, evaluating, and improving your instructions. The basics follow a simple, 4-step cycle: prompt, review, refine, and reprompt. Why do we need this? Because initial prompts rarely capture all edge cases, and outputs must be rigorously evaluated against established business KPIs. How do you manage this? You run the prompt, review the output for errors or omissions, refine the constraints to fix those issues, and run it again. In our deep dive, it is critical that organizations maintain version control of their prompts during this cycle. You are actively evaluating responses for accuracy, completeness, and strict compliance adherence to ensure the prompt matures into a reliable, enterprise-grade asset. Take a look at this cyclical flowchart representing the iterative refinement loop. We start at the top left with the initial prompt. The output generated immediately moves into the review output stage. Note the crucial branch here. During the review, we simultaneously evaluate KPIs such as accuracy and compliance. Based on those results, we move to the refine constraint stage, where we tweak instructions to fix any deviations. Finally, we reprompt system. The dotted line closing the loop back to the initial prompt indicates that this is a continuous, agile process. This visual reinforces that prompt engineering is an ongoing discipline of testing and tuning. Understanding what not to do is just as important. Let's discuss prompt anti-patterns and risks. What are anti-patterns? They are common prompt design mistakes that degrade performance and safety. The basics include overly long prompts, conflicting instructions, and simply missing necessary context. Why should you avoid these? Because these mistakes directly cause model confusion and generate incorrect information, also known as hallucinations. How do you prevent this? By applying strict constraints, removing irrelevant noise, and never overusing chain of thought when it isn't needed. Our deep dive highlights the most critical risk, prompts that accidentally leak sensitive data. Solution architects must explicitly design prompts that sanitize inputs and prevent users from injecting personally identifiable information. This ensures that prompt workflows do not cause security breaches or violate your organization's governance policies. This risk mapping diagram highlights common prompt anti-patterns. At the top, prompt anti-patterns branches out into specific failures, overly long and conflicting instructions, and missing context. Notice how both of these branches flow directly down into model confusion and hallucinations. This is where output quality completely degrades. We also have a third, more severe branch on the right, sensitive data leaks. This flows directly into a security breach and policy violation. This diagram acts as a stark warning system, visualizing exactly how poor prompt design practices lead to system failures, inaccurate data, and critical enterprise risks. Finally, we scale our efforts by building enterprise prompt libraries. What is a prompt library? It is a curated, governed collection of reusable prompt templates for the organization. The basics involve centralizing standardized prompts tailored for specific domains like HR, finance, IT, and security. Why build one? A prompt library ensures absolute consistency across teams, improves development efficiency, and enforces governance through approved guardrails. How do you structure it? Every single prompt stored in the library must include governance metadata, such as its purpose, owner, version history, risk classification, and required grounding sources. Deep diving into this, we look at the prompt maturity model. Our goal as architects is to move from level 1 basic queries all the way to level 5. At level 5, you operate a version-controlled library of reusable templates that acts as a strategic asset, ensuring safe, scalable AI across the business. Let's review this bottom-up hierarchy, illustrating the prompt maturity model. We start at the foundation with level 1, basic queries, representing simple, unstructured questions. As we move up, we reach level 2, guided prompts with basic constraints, then level 3, structured patterns using our instruction context output pattern. Moving higher, level 4, optimized, incorporates few-shot examples for precision. Finally, at the very top, we reach level 5, Enterprise Prompt Library. This apex node flows directly into our ultimate goal, governed, reusable, consistent AI. This visual perfectly encapsulates the journey from ad hoc user prompting to a mature, architecturally sound enterprise AI strategy.